Okay, last example here, example number 4 with our quadratics, and we have been talking about vertex form. So how I continually tell you, gentlemen, that process never changes. It should not matter what type of equation you're given. You should be able to take any quadratic equation, switch it into vertex form, and answer any question about that graph that we have discussed in the previous examples. So on 4, we have our generic quadratic in standard form, f of x equaling ax squared plus bx plus c. And we want to switch that to vertex form. We want to switch it to the form of f of x equaling a x minus h quantity squared plus k. And then we want to find everything about that graph. Domain, range, interval increasing, decreasing, etc. So we know that in order to take from standard form and switch to vertex form, we have to create that perfect squared quantity, which means we're going to have to complete the square. And we also know in order to complete the square, the coefficient of our squared term needs to be a positive 1. So we cannot have the a there. And so we're going to need to factor out that a. But when doing so, we only want to focus on the x's. We're not going to touch the c. Even if that quantity was divisible by a, we're going to just kind of push it aside and ignore it. So as we go through to complete the square, I'm going to factor out the a from the x's. So that's going to give me an x squared and b divided by a x. And we're not going to touch the c. We're going to just kind of push the c to the side. And now inside the parentheses, we need to figure out what is that third term that needs to be added to create a perfect square trinomial. And in doing that, we know we take the coefficient of the x term, which in this case is the b over a, and we take 1/2 of that, which gives us b over 2a, and then we square that quantity, which gives us b squared over 4a squared. And we're going to add b squared over 4a squared to the previous two terms. But now by adding that b squared over 4a squared, I have completely changed the original equation. It's not equivalent. So in order to keep it equivalent, I have technically not added b squared over 4a squared, but I have technically added b squared over 4a because the a and the a squared will reduce down. So to keep it equivalent, I need to do a minus b squared over 4a, so that I am technically adding a form of 0 so that it is equivalent to the original. And now we can finish writing our equation. So f of x is equal to a. Our parentheses is a perfect square trinomial that factors to x plus b over 2a. Remember, it will always factor to whatever 1/2 of the coefficient of the x term was. And then when we combine these terms over here, we need to get a common denominator, which is the 4a. And so we get a 4ac minus b squared up top there. And now we have our equation in vertex form. And now looking at it in vertex form, we should be able to answer everything about our graph. So first off, we would look at a, and a would tell us whether or not that graph is going to be opening upward or downward. We don't know if a is positive or negative, so we need to consider both possibilities. So I'm going to consider a start off with a greater than 0. So if a is a positive number, something greater than 0, then we know that our graph would be opening upward. We know our vertex is that hk, whatever's in the h position and the k position. So our vertex here would be the negative b over 2a, comma, the 4ac minus b squared over 4a. We know that our domain would be a negative infinity to infinity. There's no restrictions. our range, since our graph is opening upwards, our lowest y value is the 4ac minus b squared over 4a, the y of the vertex. And then we're going up to infinity from there. In terms of our min value of our graph, the lowest y is the y of the vertex here, which is that 4ac minus b squared over 4a. Our max value, well, our graph is going up, so the max value does not exist because our graph is going up towards a positive infinity. Our interval increasing, well, interval increasing, where is the graph going up? Our y is getting larger. As we move across the interval from the negative b over 2a towards infinity. Our interval decreasing, our graph's going down, our y's are getting smaller as we move across the interval from a negative infinity up to the negative b over 2a. What else do we need? Our x-intercepts. So our x-intercepts, we set y equal to 0. Now again, we could be looking at standard form, we could be looking at vertex form, but keep in mind here, x-intercepts, if I set y equal to 0, if I go back to the original, 0 equals ax squared plus bx plus c for any quadratic. What always works to solve for x, for our x-intercepts, that's when we are using our quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So our x-intercepts would be that comma 0. And our y-intercepts, or y-intercept, again, we can go and look back at the original equation that's in standard form, and our y-intercept is always this c of our standard form equation. So our y-intercept is 0, comma c. And I think that's all that we needed to find. And I am going to let you finish and redo this, considering that if a were less than 0. So if a is less than 0, what would all of this information be in terms of min-max values, interval increasing, decreasing, etc. Okay, there you go.